So we will take few examples. Yes, okay. Consider, okay, so consider an LTI system. We usually in signals and systems, most of the time we talk about what LTA system is. Relaxed LTA system means what? Initial conditions are zero. Okay, so even though I don't mention that it is relaxed or initial conditions are zero, it is taken as granted. If initial conditions are not zero, then I will mention that explicitly. Okay, so consider an LTI system, okay, with LCCDE. What does it mean? Linear constant coefficient differential equations as given below. Consider an LTA system with LCCDE as given below. So let us take d square y of t divided by dt square plus 5 times, okay, so plus 5 times dy of t by dt plus 6y of t equal to x of t. Okay, so d square y of t by dt square plus 5 times dy of t by dt plus 6y of t equal to x of t. So an LTA system is defined in this form. So question is, first question, let us say find the corresponding, okay, so find the corresponding frequency response. So I'll say directly h of j omega. Okay, so find h of j omega. Okay, right. Next, second one, find the impulse response of the system. Okay, so this topic is very important here. Many times they have asked this. Which one? Linear constant coefficient differential equation. So when we see old gate questions, you will understand the importance of this topic. Okay, third question, find the output of the system. Find the output y of t if the input is okay, let us take x of t to be equal to e power minus 2t u of t. Okay, find the output of the system if the input is x of t equal to e power minus 2t u of t. Okay, so let us solve this. First we will find the frequency response of the system. Okay, so how do you solve? Taking Fourier transform. Okay, so taking the Fourier transform of differential equation, what do we get? We get, okay, which property we have to use? We have to use both linearity property and differentiation in time domain. So you will get how much here? J omega whole square, because you are differentiating twice, multiplied with y of j omega plus 5 times j omega y of j omega plus 6 times y of j omega equal to x of j omega. So from this you can easily see that y of j omega divided by, I'm skipping one step in between which is easy to find out. So y of j omega is common on the left hand side, bring x of j omega down, so that should be equal to 1 divided by j omega whole square plus 5 times j omega plus 6. So that would be, but we know that y of j omega by x of j omega is how much? That is the frequency response of the system, which is equal to h of j omega. But okay, yeah, that solves the first problem. Okay, so what is the second problem? We have to find the impulse response of the system. So to find the impulse response of the system, we know that impulse response of the system and frequency response of the system, they form Fourier transform pair, and hence what is that we have to find out? We have to find out the impulse response of the system from the frequency response. Okay, so but before we go into that, let us do the partial fraction expansion of h of j omega. Okay, h of j omega is j omega whole square plus 5 j omega plus 6. So if you do the factorization of the denominator, you get 1 by j omega plus 2 multiplied with j omega plus 3. That's easy to find out. Okay, so denominator we can factorize like this, and hence what will be the partial fraction expansion here? For first one, replace j omega with minus 2, so you will get to 1 by j omega plus 2, and then replace j omega with minus 3, so you will get minus 1 by j omega plus 3. So that is our h of j omega. But what question is, what we have to find the impulse response. So to find the impulse response, we have to take the inverse Fourier transform. So what is inverse Fourier transform of 1 by 2 plus j omega? We know that that is e power minus 2t u of t minus, and what is the frequent impulse, which signal will have 1 by 3 plus j omega as the Fourier transform? That will be e power minus 3t u of t. So that is the impulse response of the system. Okay, right. So first question we solved, which is to find the frequency response, which is given by this, and second question is we have to find the impulse response of the system, that we will get by taking the inverse Fourier transform of h of j omega. So what is the third question here? We have to find the output of the system when input is x of t. Let's take that. So what is the output of an LTA system? So output of an LTA system is nothing but x of t convolved with h of t. So this should be equal to how much? What is x of t given to be? That is given to be e power minus 2t u of t, and this fellow is convolved with e power minus 2t u of t minus e power minus 3t u of t. Okay, so by using the result which we have got, so first we will write down, we will use the distributive property of convolution. So you will get e power minus 2t u of t convolved with e power minus 2t u of t minus e power minus 2t u of t convolved with e power minus 3t u of t. So when we talked about convolution in time domain property, we have seen this result, right? What is that? This is looking like e power minus a t u of t convolved with e power minus a t u of t, means what? A equal to b. So this should be equal to t times e power minus a t u of t. So you can refer the notes, convolution in time domain property, which we have seen. Okay, next, what about this fellow? This is looking like e power minus a t u of t convolved with e power minus b t u of t. So that should be equal to e power minus a t minus e power minus b t by b minus a whole multiplied with u of t. Okay, so this would be equal to, u of t is common, we will write down t e power minus 2t minus e power minus 2t plus e power minus 3t, and this whole thing is multiplied with u of t. Okay, so we can further simplify, that's okay. So this should be equal to t minus 1 multiplied with e power minus 2t plus e power minus 3t u of t. Okay, so in that way we can get the output of the system, which is given by this. So I'll give homework, find, for the same problem, find the output y of t if input x of t equal to, okay, I'll give first one, x of t equal to e power minus t u of t. Okay, so if the input x of t equal to e power minus t u of t, and let me give second one to be x of t equal to just u of t, and third one let me give it as x of t equal to e power minus 3t u of t. Okay, so we will take these three out, finding the output of the LTA system for these three inputs as homework. Okay, so please solve the homeworks, they will really help us. Okay, so what is that we have done in this problem? Now we were given the differential equation, and from that we are asked to find out the frequency response, the impulse response, and the output of the system for a given input.